Hello there, and welcome to Sleepy Cosmic Podcast, where we wander beneath velvet skies, following ancient light on its unhurried path through time. Outside your window, perhaps the stars are peeking through. Or maybe it's overcast, the sky a soft blanket of grey. Either way, the Earth spins gently on, as it has for billions of years. Beneath our feet, an old world slumbers, wrapped in layers of stone and silence. Tonight, we wonder, what if Earth's first civilization wasn't human at all? Let's imagine ourselves drifting backward, far beyond memory, past the pyramids and painted caves. Past the rise of mammals and the bones of ancient reptiles. We float beyond the Cambrian seas, where trilobites scuttle like armoured clockwork. Still we drift, deeper, to a time when even complex life was just a distant dream. The continents are unrecognisable, smeared across the globe like slow-motion ink. Volcanoes breathe smoke into the sky, and the air itself carries strange flavours, more carbon, less oxygen, and a constant hush. There are no birdsong, no footsteps, no cities humming in the distance, just wind, water, and the slow churn of minerals becoming memory. It's quiet here, eerily so. But in this silence, our minds open to possibility. We're taught that intelligence bloomed with us, with Homo sapiens and our ancestors carving tools from flint, lighting fires, shaping the Earth. But Earth is very old, 4.5 billion years old, and modern humans have existed for only a few 100,000 of those years. Civilization as we know it, farms, writing, cities, just a few thousand, like the thinnest layer of paint on a colossal canvas. What, then, might have come before? Could Earth, in some earlier epoch, have hosted intelligent life of a very different kind, something not descended from apes, not even from animals as we know them? A life form whose culture rose and fell long before fossils could capture its story. Mainstream geology tells us this. Earth's surface is restless. Continents drift, mountains rise, oceans open and close. But more than that, rocks are recycled. The crust is eaten by the mantle, remelted, reformed. It's called subduction, and it means that traces of the distant past are not just buried, they're erased. This gives rise to a strange kind of humility. Perhaps we're not the first intelligent species here. Perhaps we're simply the first to write it down on parchment that won't burn in the furnace of geologic time. One mainstream fact worth whispering here is that Earth's crust is constantly resurfaced. Plate tectonics drive entire continents into each other, folding rock like fabric. It's why we have mountain ranges like the Himalayas. It's also why we have so few rocks older than 3.5 billion years. The planet recycles itself. It breathes slowly, and it forgets. In that forgetting, there is room for wonder. A lesser-known fact we might drift toward is the survival of ancient zircons, tiny mineral grains found in Western Australia. Some are over 4.3 billion years old. They predate the oldest rocks and hint that Earth's crust formed surprisingly early. These zircon crystals are like the whispers of a past so distant it almost escapes comprehension. And yet even they hold only chemistry, not architecture. They are not carved, not etched with intention. If something intelligent once walked or floated on this earth long before us, it left no blueprint in these grains, or perhaps not in any way we yet recognise. Astrobiologists sometimes discuss the idea of techno-signatures, evidence of technology left behind by advanced civilizations. We usually think of this in the context of aliens, radio signals, laser bursts, or megastructures orbiting distant stars. But what if we turned that lens inward? If a civilization had arisen on Earth 1 billion years ago, would we know? Astrophysicists still debate whether there is any reliable way to detect such deep time technologies. Some propose looking for chemical anomalies, strange isotopic ratios in ancient sediments that might suggest industrial activity. Others wonder if unusual layers in the geological record could mark a civilization's rise and fall, but all agree the deeper the time, the harder the trace. Time, it seems, is not just distance, it is a dissolving ocean. And so, as we begin our journey tonight, we hold this paradox gently. The Earth is ancient and fertile, a world that has known fire and ice, silence and bloom. We are its children, yes, but perhaps not its first. If you're listening now from a quiet room, maybe in the stillness of midnight or the early hush before dawn, take a slow breath with us. Let the thoughts settle like soft sediment. We may not be the first minds to wonder beneath these stars. If this kind of quiet wonder helps you rest, I'd be grateful if you tap like or subscribe. No pressure at all. Wherever you are, whether it's midnight in Manila, twilight in Toronto, or just a quiet moment in your own heart, I'm glad you're here. Now, dim the lights, maybe turn on a fan for a soft background hum, and let's ease into tonight's journey together. We drift on then, past the known, past the mapped, past even the remembered, into deep time, into what might have been. Imagine standing barefoot on a shoreline not of today but of Earth 3 or 4 billion years ago. The waves are gentle, but the air smells strange, rich with volcanic breath and unfiltered sunlight. No birds call overhead, no crabs scurry at your feet, just tide and rock, salt and silence. We're so used to thinking of the life as carbon-based. That's what we are, after all. Chains of carbon atoms wrapped in water and spark. But chemistry is wide, and early Earth, still cooling, still chaotic, offered more than one path to complexity. There's a quiet scientific idea known as the silicate hypothesis. It suggests that under the right conditions, silicon could form the backbone of complex structures, perhaps even something lifelike. Silicon sits just beneath carbon on the periodic table. It shares certain traits, it bonds with oxygen, it can form chains, and it was abundant in the early crust, far more accessible than carbon, which was still mostly locked in gas and mineral form. But silicon is heavier, less flexible, more brittle in its bonding. Most scientists agree it's less favourable for life as we know it. Still, the door isn't completely closed. Perhaps in a different temperature range, with a different solvent, maybe not water at all, silicon life could arise. We often forget that Earth hasn't always been a water world. Early on, it might have been hotter, more mineral-rich, less hospitable to carbon chemistry, but more welcoming to something else. A silicate-based system might have been less fluid, less fast, but potentially longer-lasting, more resistant to decay. One lesser-known curiosity lies in the mineral world itself. Silica forms intricate, almost biological patterns in some rocks. There are formations called banded iron stones, created billions of years ago by slow rhythmic chemical processes. Their shapes resemble tree rings or coral growths, beautiful, ordered, ancient, and, in some ways, eerily lifelike. Could those have been more than geology? Most say no, they're simply the result of repeated deposition in ancient oceans, but we can still wonder, gently. Astrobiologists still debate whether silicon could support metabolism, replication, or intelligence at all. It's not just a question of chemistry, but of complexity. Could a silicon-based system think, evolve, or even wonder, like we do? We don't know. And in that unknowing, there is space for quiet speculation. Let's imagine for a moment a world of soft minerals, slow-growing structures, silicon crystals that communicate not through neurons but vibration, resonance. Perhaps intelligence, if it arose, would not speak or walk or dream the way we do. It might be embedded into the crust itself, whispers in the lattice of stone, thoughts that unfold over millennia, not minutes. If such a civilization existed, would we even recognize it? We search for ruins, buildings, tools, art. but a silicon intelligence might leave behind different relics. Not stone carvings, but patterns in magnetic alignment. Not metalwork, but shifts in crystal growth. Not books, but subtle disruptions in isotopic layers, buried far beneath our feet. And if these beings arose early, before plate tectonics took hold, before the ocean settled, then their world would have vanished under magma and shifting crust. Not with a bang, but with a slow, geological sigh. It's humbling to think how fragile memory is on a planetary scale. Carbon-based life, ourselves included, exists in a narrow thermal window. Too cold, and our chemistry freezes. Too hot, and we unravel. But silicon could, in theory, persist in places we cannot, beneath the crust, within molten rock, or in hydrothermal vents where temperatures boil past what we consider livable. Could Earth's first sentients have dwelled in places no fossil could form? We found microbial life in Earth's crust, deep beneath the ocean floor, feeding on minerals, breathing slow, hidden lives. It's not intelligence as we know it, but it's proof that life doesn't need sunlight or air or comfort. Just chemistry. Just time. And time. Earth has had plenty of that. The first carbon-based cells we know of appeared over 3.5 billion years ago. But life may have begun even earlier. There are signs, chemical hints in rocks, that suggest biological processes happening as far back as 4 billion years. And what came before that? Geology doesn't answer easily. The record is too broken, too melted, too erased. But in that erasure lies possibility. Maybe life didn't begin with the familiar. Maybe Earth's first experiment was different, slower, stranger, less suited to fossilization. Maybe it was silicate-based, and maybe it was aware. If so, it would have watched the cooling of the crust, the first clouds forming in a once hostile sky. It might have measured time in the language of tectonics, not seasons, and when carbon life eventually emerged, when microbes began bubbling in the shallow seas, perhaps that earlier world faded, not from defeat, but from transformation. Perhaps it dissolved quietly, leaving only questions. As we drift deeper into this thought, you might feel your own body soften, like sediment settling in still water. The idea of a pre-human, pre-carbon intelligence may sound like fiction, but fiction and science often share a border, the border of what we know and what we don't yet. We hold the silicate hypothesis lightly, not as truth, but as a whisper, a maybe, and perhaps that's the gift of the night sky and of old Earth beneath it. They remind us that what we see is never all there is, that beneath the crust of certainty lies a deeper world of maybes. Tonight, we drift there together. Let's wander further now, beyond chemistry, beyond the quiet mystery of silicate minds, into the deeper folds of Earth's long memory. A memory riddled with gaps, not just from time, but from silence. There's a phrase often used in archaeology: absence of evidence is not evidence of absence, and while it's a helpful guide, it rarely survives the leap into deep time. The farther back we look, the more the ground forgets. Stone weathers, mountains crumble, oceans claim their secrets, and sediment covers everything. What if Earth's earliest intelligent beings didn't just vanish, but were untraceable by design or by nature? Some scientists and philosophers have gently speculated about what are called shadow civilizations, cultures that could have arisen millions or even billions of years before us, only to be utterly erased by geological processes, not buried, not hidden, gone. The idea isn't science fiction, it's scientific humility. After all, we ourselves have existed for only a blink, our oldest structures barely 10,000 years old. The oldest writing systems? Maybe 5,000. And even now in the 21st century, most of what we create is ephemeral. Our cities could vanish in a few thousand years, swallowed by jungle, desert, flood, or ice. Satellites might linger longer, but even those will fall or decay eventually. So we ask quietly, if a civilization had existed tens of millions, or hundreds of millions of years ago, long before the age of mammals, would we expect to find anything at all? Let's step into a scene. A vast unknown world in Earth's ancient past, perhaps during the Proterozoic eon, over 1 billion years ago. The skies are dimmer, the sun is younger. Life, as we know it, is microbial, painting oceans green with ancient cyanobacteria. But in some forgotten corner, could a different path have unfolded? Not carbon, not silicon, but something else, a third option, now extinct, unknown to our textbooks. Imagine a civilization not built with fire or metal, but resonance and light. Perhaps their tools were vibrational, their homes ephemeral, their record-keeping beyond matter altogether. If they encoded memory into magnetic fields, into crystal alignments, or into perishable proteins, we would never know. Mainstream astronomy teaches us that when civilizations vanish, the universe doesn't mourn. There is no trace unless that trace survives time, and time, on Earth, is not kind. One compelling mainstream fact here is that Earth's surface has been almost entirely resurfaced many times over. Not just by tectonics, but by asteroid impacts, ice ages, and atmospheric shifts. Even the ocean floors are young geologically speaking, barely 200 million years old. Older crust is consumed, eaten, forgotten. We live atop a planet that constantly erases itself, yet there are places where time slows. Caves, amber, and ancient rock formations have held whispers from the deep past, and so we wonder, could anything have slipped through? A lesser-known curiosity comes from the Great Unconformity, a puzzling gap in the rock record found across many parts of the world. In some regions, it's a missing 1 billion years. A full vertical mile of rock, simply gone, erased by unknown forces. Geologists don't agree on the exact cause. Some suggest glaciers, others tectonic uplift, or long erosion. But no one fully knows. If anything extraordinary had happened during that lost 1 billion years, something intelligent, something structured, it would likely be gone with that vanished stone. It's not a claim, just a possibility. Astrobiologists still debate whether intelligence is inevitable, given enough time, or whether it's a cosmic accident, rare, fragile, and unrepeatable. On Earth, it seems intelligence has only arisen once, but that presumes we have the full record. We don't. And that's the quiet terror and beauty of deep time. It doesn't just hide things, it consumes them. But let's soften this thought. If a pre-human civilization once flourished and then faded, perhaps it did so with peace. Perhaps it rose, reached its natural peak and stepped back into the planet without violence or collapse. Not every end need be tragic. You might wonder, here in the dark, what such a civilization would think of us. Would they see us as children, as inheritors, as noise, or would they feel nothing, long gone with no memory left to recall? That too is a kind of mystery, the mystery of silence. If you're lying down now, feeling the hush of your room settle around you, perhaps you can sense how big these questions are and how small we are beside them. But not in a way that makes us feel lost, in a way that makes us feel held. Because Earth is not just a rock in space, it's a memory palace, a vessel of forgotten dreams, even if those dreams leave no trace. And to wonder about them is to share in something old, something sacred. We don't know if Earth's first civilization was human, but we do know that we're not the beginning of the planet's story, not even close. As we drift further through this twilight corridor of thought, we arrive at a curious mirror, the Fermi paradox. You've likely heard of it. It asks, if the universe is so vast and old, brimming with stars, planets, and possibilities, why haven't we heard from anyone else? We usually aim that question outward, into the stars. But tonight let's gently turn it inward. What if we asked, if Earth is so ancient and fertile, why haven't we found any trace of a previous intelligent species right here? This is the Fermi paradox, folded back on itself, a paradox not of the stars, but of our own soil. Mainstream science acknowledges how staggering Earth's timescales are. Complex animals have only existed for a few 100 million years. But Earth has been here for over 4.5 billion. That leaves billions of years unaccounted for. Billions of years during which intelligent life might have come and gone, leaving behind only silence. When we look up at the night sky, we often imagine civilizations far away, on Proxima Centauri, on a distant exoplanet somewhere behind the velvet veil of nebulae and light years. But what if the strangest mystery wasn't out there, but under our feet? We spend vast resources listening for alien signals, radio waves, laser bursts, repeating patterns. We build telescopes that scan the heavens for Dyson spheres and distant flickers of industry. But on Earth, we assume that we already know the story, that the fossil record is complete enough, that we've found what needs to be found. And yet, has any species in Earth's history ever looked beneath the mantle of its own memory, quite the way we try to look beyond the stars? There's something hauntingly symmetrical about it. We search for intelligent life out there, and we might have missed it here. A mainstream concept in paleontology worth remembering is the fossilization bias. Most life forms never fossilize. The conditions must be just right. Rapid burial, low oxygen, minimal disturbance. Soft-bodied creatures, for instance, often leave no trace. Whole ecosystems can vanish from the record simply because no sediments captured them. The same holds true for civilizations. Unless a structure is buried quickly and preserved, time will dissolve it. Metal corrodes, concrete crumbles, organic material returns to the soil. 100,000 years from now, even our greatest cities may be no more than ghost impressions in the rock. This is where the inward Fermi paradox begins to echo more clearly. If intelligent life arose on Earth long before us, millions or even billions of years ago, could it have vanished so thoroughly that we wouldn't even know where to look? Astrobiologists still debate how to distinguish natural geology from artificiality in deep time. Could a perfectly regular pattern in mineral veins be natural, or might it be a buried relic of engineering? Could a symmetrical ridge on the ocean floor be a forgotten structure, or just a fluke of plate movement? Most would lean toward natural causes. It's safer, simpler. But in that caution, might we be overlooking something rare? We know how quickly time washes things away. Consider the city of Mohenjo-Daro, once a thriving centre of the Indus Valley civilization. Just 4,000 years later, much of it has returned to dust. Or the jungle-covered pyramids of Central America, hidden from view until satellites saw their outlines. Even modern ruins, abandoned for a century or two, become nearly invisible beneath vines and soil. Now stretch that forgetting to 1 million years, 10 million, 100 million. Even if evidence had once existed, who's to say we'd still be able to detect it? A lesser-known idea, proposed softly by a few researchers, is the possibility of non-technological intelligence. Civilizations that never industrialized, never built machines or cities, but still thought, dreamed, and perhaps even spoke. If such a species arose, let's say in the late Precambrian, what signs would they leave? Maybe none. We assume intelligence must build, must invent, must alter its environment, but perhaps not. Perhaps there are ways of being brilliant that leave no scar. Could such beings have existed in the ancient forests, or beneath the shallow seas, organizing, creating, perceiving the world in complex, ephemeral ways? It's uncertain if intelligence must lead to industry, or if that's just our path, a single branch on a very wide tree. And so, the inward Fermi paradox lingers like a soft echo, not demanding answers, just inviting us to pause, to wonder. You may be lying down now, your breath slower, your body heavier. Perhaps this question settles into the quiet folds of your thoughts. What if we're not alone in the cosmos, and not even the first to ask? That idea doesn't need to be frightening. It can be calming, even comforting. It means we are part of a longer story, a deeper weave of time, not the first note, not the last, just a gentle harmony in a vast cosmic song. Let's continue our drift into that silence, a silence that might not be empty at all. Picture the Earth not as it is now, but as it might have been hundreds of millions of years ago. A world without continents as we know them, a single, massive landmass, or scattered island arcs adrift on a hotter sea. The sky tinged orange from volcanic haze, the air heavy, dense, alive with a quiet simmer of transformation. Now imagine this. A civilization once existed here, long before mammals, before even the dinosaurs. Not merely erased by time, but swallowed completely, consumed by the very body of the planet. This is the story that plate tectonics quietly tells. It's a process most of us learn in school. The crust of the Earth is broken into shifting plates that ride atop the molten mantle. These plates move slowly, colliding, sliding, pulling apart. But they also dive, one slipping beneath another in a process called subduction. When that happens, entire regions of the crust are drawn down into the deep Earth, heated, melted, and reformed. What this means, in quiet but staggering terms, is that Earth doesn't just bury its past, it eats it. A mainstream geological fact: the oldest oceanic crust on Earth is less than 200 million years old. Everything older than that has been recycled, melted down and reborn. The deep sea floor has no memory beyond that. As for continental crust, some patches are older, 3, even 4 billion years in isolated cratons. But much of it too has been weathered, shattered, or transformed beyond recognition. In this geologic churn, even entire mountain ranges disappear. So what hope would fragile relics of intelligence have? If an early civilization ever built anything, cities, monuments, machines, those artifacts would have needed extraordinary luck to survive, not just from erosion and flood, but from being drawn beneath the planet's skin. And once something enters the mantle, it ceases to be what it was. This is where our wondering deepens. Perhaps such a civilization didn't fall in the usual way, not through war or collapse or slow decline. Perhaps it simply drifted into oblivion beneath the crust, erased not by failure, but by Earth's own hunger for renewal. There's something strangely serene in that image, a forgotten people watching their world change, not violently, but with the inevitability of tides and time. Perhaps they accepted it, perhaps they fought it, or perhaps they lived in such harmony with the planet that their departure left no scar. A lesser-known geological clue here is that of xenoliths, fragments of ancient crust sometimes brought up from the deep mantle by volcanic eruptions. These stones are messengers from Earth's unreachable past, bearing chemical signatures that hint at the surface worlds they once belonged to. Sometimes they contain anomalies, odd mineral compositions, strange isotopic ratios. Most are explainable, but some leave questions. Astrophysicists and geochemists still debate whether xenoliths might preserve evidence of past surface conditions now completely lost. It's uncertain if anything complex, let alone artificial, could survive that journey through fire and pressure. But the possibility remains open just enough to whisper. And what if a civilization anticipated this fate? What if, knowing their crust would someday vanish into the mantle, they encoded their knowledge in forms that could endure? Not metal, not paper, but patterns, geometry, recurring structures in rock chemistry, fields of magnetism that span continents. We wouldn't recognize them as messages, not yet, because we're still learning how to listen. In a way, we're geological infants. only just beginning to read the history written in stone. The science of paleogeography is still unfolding. Every year we redraw our maps of the ancient world, and each revision humbles us further. We used to think continents were fixed, that mountains were eternal. Now we know they wander and vanish. Time is not a line, it's a restless tide. And Earth? Earth forgets. You might feel a gentle weight in your chest hearing that. The idea that so much can vanish without trace. But remember, forgetting is part of Earth's rhythm. It makes space for new life, new stories, new dreams. Still, we can't help but wonder, what stories came before? If you're drifting now, soft and still, let yourself imagine standing at the edge of a vanished continent, one that no longer exists in any map. Beneath your feet lies not sand or stone, but memory. A memory so deep, so old, that it has become indistinguishable from the earth itself. And in that place, perhaps the silence speaks, not with words, but with a feeling, a hush, the hush of something that once was and might be again. If we lean in closely now, past the tectonic murmur, past the erased crust and melted stones, there's another kind of whisper waiting, not in the rock, but in the record of life itself. We begin with stromatolites. To the casual eye, they look like layered rocks, strange domed structures rising from the shallow waters of remote coastlines. Some alive, some fossilized, some little more than lumps of mineral and algae. But these quiet mounds are among the oldest living things on Earth, microbial mats that have persisted in one form or another for over 3.5 billion years. They breathe, they build. Slowly, over time, they trap sediment and create delicate structures, layer upon layer, year after patient year, and they've seen it all. From the ancient seas of the Archean Aeon to today's quiet tidal flats, stromatolites have endured more planetary changes than we can truly grasp. They are the biological timekeepers of Earth, and we wonder, did they ever witness something strange? A shimmer in the water, a structure on the shore, a shape not made by wind or tide. Perhaps in some vanished epoch, the world was not quite as empty as we think. The thought may sound fanciful. But let's remember, a mainstream scientific truth is that stromatolites are among the only surviving windows into life's deep past. Fossilized examples date back over 3.4 billion years. These ancient colonies of cyanobacteria once transformed the very atmosphere, releasing the oxygen that would make all complex life possible. In that way, they're not just survivors, they are shapers of Earth's destiny. But what if they weren't alone? We tend to view early life as simple, primitive, and in many ways it was. But some researchers suggest that complexity doesn't always follow a straight line. That bursts of evolution might occur and then vanish, that a fragile intelligence could bloom briefly, even once, and then be erased. In the soft, shallow seas of early Earth, such a bloom would leave little behind. This brings us to a lesser-known idea, the Precambrian complexity window, a proposed time over 600 million years ago, when multicellular organisms might have briefly flourished in forms we haven't yet discovered, or perhaps no longer recognize as biological. Their bodies may have been soft, gelatinous, or entirely unlike the architectures we classify today. It's uncertain if any advanced behavior ever arose in that ancient period, but if it did, the evidence would be whisper-thin, a ripple in silt, a pattern lost to metamorphic rock. And yet, the stromatolites were there, still quietly building, still breathing in sunlight, still laying down their mineral scrolls. Could they have recorded anything? Not in writing, of course, but in layers, in the rhythm of their growth, in subtle shifts of mineral content, in the shapes of interruption. Astrobiologists sometimes speak of biosignatures, traces of life in the form of isotopic ratios, specific molecular residues, or chemical markers that reveal biological activity. But could there also be event signatures, interruptions in biological patterns that hint at external influence. For example, a sudden change in the shape or structure of stromatolites across multiple locations, anomalies in their layer composition that can't be explained by natural forces. These could point to shifts in ocean chemistry, or to something else, to a tension. It may sound speculative, and it is, but deep time invites us to gently stretch the frame of the possible. You might be wondering, how could we ever distinguish between a natural disruption and a sign of intelligent interference? And the answer is, we may not be able to, not yet, maybe not ever. But to wonder is to listen. And in the rhythm of the stromatolite, its quiet patience, its ancient breath, there is room for that listening. We're not the first to touch the earth with awareness. Life has been touching it since the beginning, most of it without eyes, without language, but perhaps not without curiosity. If you're still with us, eyes closed or half-lidded, perhaps your thoughts are drifting now, swaying like kelp in an ancient tide. Imagine standing beside one of these stone-like organisms, feeling the sun warm your skin, listening not with ears but with time. The stromatolite, silent beside you, has no need to speak. It remembers, and perhaps, in some secret way, it witnessed. Let's breathe in now, gently, and slide further back. Deeper than fossil seas, beyond microbial mats and tectonic loss, into a time even geology struggles to illuminate. There's a peculiar silence in the record before the Cambrian explosion, those few 100 million years just before complex life burst onto the scene. This period, often considered the Earth's great biological prelude, is filled with shadows and fragments. But it's also a window, a space where we might imagine what's been forgotten. Some call it the Precambrian dark. What if a civilization had risen then? A flicker, brief but bright, in that long expanse of quiet. Scientists define the Cambrian explosion as a rapid diversification of life that occurred roughly 540 million years ago. Prior to that, Earth's biosphere was dominated by soft-bodied, mostly microscopic organisms. But after, the fossil record changes dramatically, suddenly full of shells, spines, eyes, limbs. A mainstream fact worth holding in our palm: the Cambrian explosion is well documented in places like the Burgess Shale in Canada, where fossil beds preserve creatures with astonishing clarity. Trilobites, anomalocaridids, and spiny worm-like beings fill the stone like a sudden cosmic gallery of complexity. But what came before? That's where the hypothesis of an Epoch Zero quietly waits. This idea, fringe but poetic, suggests the possibility of a prior wave of intelligence, not human, not even animal in the traditional sense. Perhaps microbial minds, perhaps chemical collectives, perhaps something no longer imaginable. We don't claim this happened. But Earth gives us just enough silence to wonder. There are fossils from before the Cambrian. The Ediacaran biota, for example. Soft, enigmatic forms shaped like fronds, discs, and quilted mats. No eyes, no mouths, just presence. Their place in life's tree is still debated. Some think they were failed experiments in complexity. Others believe they were precursors to modern animals. A few even suggest they may have followed a separate, now extinct biological path. A lesser-known point here: some Ediacaran organisms may have grown by a unique process called fractal branching. Not cell division in the way we know it, but a self-similar unfolding, like a fern or a mathematical pattern repeating itself at every scale. Could such a life form have achieved something more than growth? Astrobiologists still debate whether intelligence must follow a pattern like ours: nervous systems, sensory input, motor output, or whether entirely different architectures could give rise to awareness. Could a fractal organism, embedded in a microbial mat, develop coordination, pattern recognition, a kind of distributed cognition? We can't say for sure, but in the space between certainty and silence, imagination blooms. Imagine, if you will, a world before vertebrates, before predators, before the noise of complex motion. a world of stillness and chemical gradients. In this hush something stirs, not with sound, but with pattern, not with language, but with rhythm. Perhaps these early organisms organised their environment. Perhaps they constructed vast, organic mats across the ocean floor, structured, layered, deliberate. Not cities, not machines, but bioarchitectures made of themselves. And perhaps they watched the tide of life change. As new forms emerged, more aggressive, more mobile, they receded, or adapted, or dissolved into the sediment, their knowledge absorbed back into the silence. It's uncertain if any intelligence ever arose in the Ediacaran seas. Most scientists believe not, that complexity had not yet ripened into cognition, that the spark of thought came later. But a few keep the question open, not because they believe in hidden empires, but because Earth's early history is written in a language we're still learning to read. You might be lying very still now, the world around you quiet and dim. Let your breath drift like sediment in ancient water. Imagine the seafloor beneath you, soft and glowing, alive with slow, deliberate life. Not watching, not thinking, and yet, perhaps, aware in some way we don't yet understand. A presence, a memory, a hush that came before the storm, and when the Cambrian explosion did come, with its new eyes, its biting jaws, its wild motion, it was as though the curtain rose on a new act of the planetary play. But that doesn't mean the earlier acts weren't real. They're just forgotten, folded into stone, lost to time, and maybe, in rare places, still whispering beneath the crust. As we drift onward, we turn our gaze not just back in time, but outward, gently expanding our frame. There's a quiet symmetry between beginnings and endings, between origins and dispersals, and in that symmetry, another question unfolds, tender, strange, and rarely asked. What if Earth was not only seeded by life from beyond, but also served as the origin of life that travelled outward? We often hear of panspermia, the hypothesis that life came to Earth from somewhere else, maybe from Mars or even further afield, riding on meteors or dust carried by time and chance. Some even wonder if the molecular seeds of life were delivered by comets, bringing not just water but potential. But tonight, let's imagine the mirror image of that idea. What if intelligent life arose on Earth long, long ago and left? Not in vast ships or gleaming cities, but in small deliberate steps. Not like us with engines and mathematics, but differently. Slower, stranger. The thought may seem improbable, and yes, it likely is. But it opens a doorway to a tender curiosity. Imagine a pre-human civilization, not of apes or mammals, but something older, quieter. A being or collective that reached a threshold of awareness, looked up at the stars and dreamed not of conquering space, but of joining it. Perhaps their knowledge wasn't technological in our sense. Perhaps they understood biology more than machinery. Perhaps they encoded themselves into spores, seeds, crystalline forms, not passengers in rockets, but travellers of deep time, drifting outward on solar winds, caught in comet tails, woven into particles of dust. Mainstream science tells us that microbial life can survive in the vacuum of space, at least for short times. We've found bacteria that endure extremes of heat, cold, pressure, and radiation. There are species on Earth called extremophiles that can live in boiling acid, in Antarctic ice, even in the hearts of nuclear reactors. One mainstream fact worth settling on here is that tardigrades, tiny water-dwelling animals also called water bears, have survived direct exposure to space. In 2007, they were carried aboard a European satellite and exposed to the vacuum and radiation for several days. Many survived. Some even reproduced after returning. Life is astonishingly resilient, so it's not unthinkable that fragments of biology, if carefully protected, could make the leap from one world to another. And if life can travel passively, might intelligent life choose to send itself? A lesser-known curiosity lies in a project called Genesis, a proposed future mission that would send synthetic DNA to habitable exoplanets, allowing life to begin anew. Not humans, not civilizations, just seeds, code, the quiet spark of beginnings. Now imagine if that's already happened, not from us but from them, from the intelligence that may have walked or drifted across a forgotten Earth. Astrophysicists still debate whether panspermia in either direction is probable. Some say the distances are too vast, the timescales too long. Others point to the sheer number of planets, billions upon billions, and the unimaginable duration of cosmic time. It's uncertain if any species has ever sent its children to the stars, but it's possible, and possibility is enough for tonight. If such a civilization once lived here, they may have seen the end coming. Perhaps it was a slow change, atmospheric collapse, solar brightening, shifting magnetism, or perhaps it was simply an understanding that their time was done, that Earth would forget them and something else would rise in their place, and so they left, not as conquerors, but as gardeners, sending traces of themselves into the void, not to be remembered, but to be reborn. Maybe we are their echo. Maybe we carry their dreams in the symmetry of our cells, the structure of our DNA, the restless reach of our curiosity. It's a soft idea, but a profound one, that we, in all our noise and wonder, might be the second movement of an ancient symphony, that we might walk the same paths, speak to the same stars, gaze at the same moon, and not know why it feels so familiar. You might be lying quietly now, with your breath slow and steady, feeling your own small gravity draw you into the mattress, into the hush. The thought that life on Earth could have once reached outward, long before us, does not demand belief. It only invites reverence, because the night sky is not just full of stars, it is full of questions, and maybe of memories. Let's drift now into a gentler question, not of bones or buildings, but of breath and chemistry, into the most subtle traces that might remain long after cities crumble, long after memory fades. We ask, could Earth's rocks carry a hidden signature? Not a monument, but a quiet fingerprint. Not an artifact, but a pattern in the very elements themselves. This brings us to isotopes. Isotopes are versions of the same element, but with different numbers of neutrons. Carbon has several. So does oxygen. And when living things interact with their environment, they leave behind a chemical signature, ratios of isotopes that reflect life's processes. For instance, plants prefer the lighter carbon-12 isotope over the heavier carbon-13. So when we find ancient sediments enriched in carbon-12, we recognize it as a probable sign of past life. This is one way we trace the earliest biology, through these faint whispers in the elemental ratios. Now imagine, quietly, that a civilization far older than us once existed, not for a few centuries, but for hundreds of thousands, or even millions, of years. If such a culture developed industry, energy use, agriculture, or large-scale processes, it would have altered the planet, perhaps not with skyscrapers, but with chemistry. Could such alterations still be detectable today? A mainstream fact here: geologists can identify distinct chemical signatures from the Industrial Revolution in modern sediments. Spikes in carbon dioxide, sulfur compounds, radioactive isotopes from nuclear testing. All of these form part of what scientists now call the Anthropocene, our age, the age of humans, written not in stone, but in isotopes. So the question becomes, could a similar signal from a forgotten intelligence lie buried in older layers? This is the soft edge of what's known as the Silurian hypothesis, a thought experiment proposed by scientists to ask, would an industrial civilization, predating humans by many millions of years, be detectable in the geological record? Not as a claim, but as an invitation to consider the limits of preservation. They note that even major industrial activity might be hard to detect after tens of millions of years, especially if the civilization didn't last long, especially if it avoided certain technologies, especially if it knew how to live lightly on the Earth. But there might still be echoes, changes in carbon ratios, unusual deposits of rare earth metals, synthetic compounds without natural analogues. Strange fluctuations in oxygen levels, a global shift in nitrogen cycling. We might not recognise them at first. After all, we're only just learning how to read Earth's deeper chemical history. We're fluent in the recent chapters. But the older pages are blurred, torn, overwritten. There's a lesser-known detail here. In some ancient strata, dating hundreds of millions of years back, we found brief, sharp changes in atmospheric composition, short-lived dips in oxygen, abrupt warming or cooling events, sudden influxes of certain elements. Most are explained by volcanic activity, asteroid impacts or mass extinctions, but not all. Astrobiologists still debate whether such changes could, in theory, be linked to technological activity. It's uncertain if these blips represent natural cycles, or perhaps something more deliberate, something planned, something lived. Again, we don't claim this is true, only that the possibility makes us look closer, listen longer, because the Earth speaks in patterns, and sometimes patterns repeat. Imagine now a vast plain, long buried, where factories once stood, powered not by coal or oil, but by something forgotten, clean, efficient, but traceable. Perhaps their emissions drifted into the sky, changed the chemistry of rain, left behind a layer of altered stone. We don't find ruins, we find the air they changed. You might be listening now with your body at rest, your thoughts half a step from dreaming. Let this idea settle gently, that our planet has a memory deeper than fossils, that the air, the soil, the sea, all remember what passed through them. And if Earth once held another intelligence, long before us, long forgotten, it may have spoken not in words, but in isotopes, ratios, shifts, echoes. And perhaps, one day, we'll learn how to read those echoes as stories, as history, as quiet confirmation that we were not the first to ask, to build, to wonder. But even if we never know for sure, the wonder itself remains, and in that wonder we find a deeper kind of presence. Let us drift now from stone and chemistry to water, to the oceans, ancient, vast, and always in motion. If Earth has a subconscious, a dreaming mind beneath the surface, perhaps it lives in the sea, and so we ask gently, what if the first intelligent civilization on Earth was not land-based at all? We tend to imagine intelligence walking upright, manipulating tools, building cities on firm ground. But the ocean is older than any continent and far more stable. For billions of years it was the only home life had, and even today it holds more than 90% of Earth's biosphere. What if sentience bloomed in the deep? It's a quiet, often overlooked possibility, that the first awareness on this planet may have emerged not in forests or grasslands, but in the pressure-crushed stillness beneath ancient waves. Not human-shaped, not mammalian, but fluid, slow, and perfectly at home in darkness. We know from modern studies that octopuses and certain whales exhibit signs of complex cognition, problem-solving, communication, even play. These animals evolved independently from us, following completely different biological paths. Yet they arrived at something that feels familiar, a kind of awareness that stares back. A mainstream scientific fact to hold in our thoughts: octopus brains are not centralized like ours. 2/3 of their neurons are spread throughout their arms. Each limb can move, react, even learn independently. It's a decentralized intelligence, one that challenges our assumptions about what minds must look like. If such creatures exist today, evolved in relative isolation, what might have come before? The ocean hides nearly everything. Its floor is vast, unmapped, and constantly shifting. If an intelligent species had evolved there, hundreds of millions of years ago, what evidence would remain? Perhaps none. Soft bodies rarely fossilize. Structures built from organic material dissolve in salt water, and even stone carvings, if left underwater long enough, erode into unrecognizability. But absence of evidence is not evidence of absence. A lesser-known curiosity. Beneath the Pacific Ocean lie vast flat plains called abyssal plains. Some are remarkably featureless, others contain strange organized patterns, lines and ridges visible only from satellite bathymetry. Most are likely natural formations, but a few are unexplained, their shapes too regular, their placement too curious. Could they be remnants? Could they be echoes? Astrobiologists still debate the likelihood of aquatic intelligence developing advanced technology. It's uncertain if marine species could harness fire, smelt metals, or invent complex tools. Fire, after all, does not burn underwater. But must all technology look like ours? Perhaps an aquatic civilization would think differently. Not in machines, but in biology. Not in buildings, but in networks. Perhaps their architecture would be living coral, engineered currents, or synchronized swarms of organisms functioning as one mind. They might not build, they might grow, and their messages might not be carved or painted. They might be sung, long, low-frequency songs that travel for hundreds of miles through the sea. We know that some whales today still use these kinds of calls. Songs that change over time, songs that spread, echo, and evolve. Imagine a civilization whose language was layered into whale song, passed from generation to generation, carried across oceans like a tide of memory. It would not be visible to us, not as ruins, not as artifacts, only as a shifting living pattern in the sonic background of the deep. Now imagine such a species sensing its own end. Maybe the waters warmed, maybe food chains collapsed. Or maybe they simply evolved away from complexity. But before they faded, they left behind a gift, a seed perhaps, encoded in DNA, or a whisper hidden in the genome of some modern marine species waiting to be read. We don't know, but we listen. And the ocean, vast and ancient, keeps its secrets well. If you're resting now, eyes closed, let your mind sink slowly beneath the waves. Imagine yourself weightless, surrounded by bioluminescent trails, currents that carry memory, pulses of sound that stretch back into prehistory. Here, the silence is not empty. It's filled with the slow drift of time. With thoughts that might not be gone, just deep, just hidden. Perhaps the first minds on Earth didn't stand beneath the stars. Perhaps they swam. We surface now, gently from the ocean's hush, and turn our gaze skyward, to our sister planet, forever veiled in cloud and mystery, Venus, so close, so bright. Often the first star to appear at dusk, and the last to fade at dawn. We've named her after beauty and love, but she is a world of extremes, blistering heat, crushed skies, winds that scream through sulphuric clouds. And yet, Venus may once have been gentle. Tonight, let's imagine not just Earth's forgotten past, but Venus's. Because if Earth could host an intelligence before us, so might have she. A mainstream planetary fact. For much of its early history, Venus may have had oceans. Models suggest that for up to 2 billion years the planet may have been temperate, capable of supporting water on its surface. Its atmosphere then was thinner, cooler, more Earth-like, and then it changed. The sun brightened, the greenhouse effect took hold, and slowly the planet transformed into the inferno we see today. Its oceans boiled away, its surface reshaped, its sky sealed beneath thick reflective cloud. But 2 billion years is time enough for a story. What if Venus once held life? Not microbes only, but complexity, culture, memory. Not human, of course, not even Earth-like necessarily. but intelligent. Perhaps they lived in the shallows of vanished seas, or clung to twilight coasts. Perhaps they lived slowly in glassy cities that breathed with the planet's pulse. Perhaps they walked beneath soft golden skies and watched their world change, not with fear, but with knowing. If so, they would have seen it coming. Runaway climate change does not arrive in a day. It begins as a whisper, a subtle warming. And if their science was anything like ours, they would have tried to understand it, tried to adapt, or escape. But where would they go? Some theories suggest that Venus's inhabitants, if they existed, might have looked to Earth, a nearby haven, still cool, still young. A less-known curiosity, meteorites from Venus may occasionally arrive on Earth, just as Mars rocks have. During massive impacts, chunks of planetary crust can be ejected into space, drifting for millions of years before falling into another gravity well. Some scientists speculate, quietly, that microbes could survive such a journey. And if so, might something more complex once have tried? Astrobiologists still debate whether Venus could have supported life long enough for intelligence to evolve. It's uncertain if a temperate period truly existed, or if the models are too optimistic. Surface conditions today are hellish, hotter than any kitchen oven, with pressures that would crush a submarine. Probes that land survive only minutes, and yet the clouds remain curious. At certain altitudes, Venus's atmosphere becomes cooler, more Earth-like, and in those high, drifting layers, strange chemistry has been detected, compounds like phosphine, which on Earth are associated with life. The data are inconclusive, the debate is ongoing, but the mystery lingers. Could something live there still? Perhaps not on the surface. But in the clouds, suspended in acidic droplets, floating with the wind, it's a quiet, haunting idea, and it makes us wonder, if a civilization once thrived on Venus, could they have left anything behind? Not buildings, not machines, but signals. Perhaps they looked outward. Perhaps they reached Earth with probes, with knowledge, with whispers encoded in gravity waves or magnetism. And perhaps, in their final days, they tried to warn us. Perhaps we didn't or couldn't hear. Or perhaps we are the outcome of that warning, the inheritors of a second chance. You might be lying in stillness now, your thoughts circling slowly like clouds. Let the idea settle in your chest, that our sister planet, the brightest jewel in the night sky, may be a graveyard of forgotten beauty, that beneath her golden hush lies a silence not of emptiness, but of memory. And when we look to Venus glowing low on the horizon, we're not just looking at a planet. We're looking at a mirror, a warning, and maybe a story left unfinished. Now we rise from the surface of planets and begin to look toward the space between them, not for signs of life in motion, but for remnants, silent, drifting things that might once have belonged to someone, relics that orbit quietly, unnoticed, perhaps forever. Could Earth's first intelligent civilization, if it existed, have left something behind in space? Tonight we wonder about the skies just above us. Not the distant stars, but the quiet shell of orbits that surrounds our world. An orbital graveyard, a place where objects linger long after their purpose is forgotten. On Earth, nature reclaims everything: wind, water, roots, and rust erase our traces quickly. But space does not forget so easily. Satellites, once launched, can remain in orbit for centuries. Some, in higher orbits, will persist for tens of thousands of years before finally falling into the atmosphere and burning away. It's a mainstream astronomical fact that objects in geostationary orbit, roughly 36,000 kilometers above Earth, remain extremely stable. Barring collision, they will stay in place indefinitely. A satellite placed there could, in theory, outlast every building on Earth. And so we ask, If a pre-human civilization once reached space, could any of their machines still be up there? Not blinking, not transmitting, just drifting. One lesser-known detail: the United States Space Surveillance Network actively tracks more than 20,000 pieces of human-made orbital debris. But many objects are too small or too distant to detect. Some are decades old, others no one remembers launching. Now imagine if among these known objects, there was one we didn't make, a fragment, a shell, a quiet thing, shaped by hands or minds no longer here, not shining, not signalling, but still there. Astrobiologists and SETI researchers have occasionally floated the idea of archaeological artifacts in space, not radio signals, but physical things, probes, beacons, or monuments left behind by long-dead civilizations. These are sometimes called lurkers, objects that might hide in stable orbits, silently watching. Most assume these ideas apply to aliens. But what if one such artifact was human, or nearly human? If a prior species on Earth reached orbit, even briefly, some trace might still remain, especially if they understood stability, especially if they placed something in a high orbit, or at a Lagrange point, those gravitational sweet spots where an object can hover indefinitely between Earth and Moon or Earth and Sun. We've looked, of course. Our telescopes and radar arrays scan the sky, but there are limits. We don't yet have a complete map of all orbital objects, especially at extreme distances or in shadowed regions, and some orbits, those far from Earth or inclined just so, are difficult to detect from the surface. It's uncertain if we've missed anything, but the uncertainty itself opens a door. Let's drift now into imagination. You're floating high above Earth, above the pull of air and weather. Below you, clouds swirl across continents, cities blink softly in the darkness, and the blue of oceans curves along the horizon. Above, the stars burn steady, unshaken by time. And there, just beyond your field of view, an object turns, smooth, silent, covered in dust and micrometeorite scars. It does not glow, it does not move, it simply exists, locked in place like a memory. Perhaps it was once part of something larger, a station, a vehicle, a transmission array. Perhaps it once held knowledge, or stories, or the voices of a people now long vanished. Now it is mute, but not gone, and maybe not alone. There is a quiet poetry to the idea that the sky holds more than light, that among the satellites and debris of our era, there could be visitors from another time, from Earth. Yes, but from a chapter erased by geology and fire. If you're lying still now with the ceiling soft above you or the night sky visible beyond your window, take one breath for the space just above us, for the orbits that circle in patient silence, for the possibility that something ancient still moves in the dark, not calling out, just watching, waiting, or simply drifting, lost in its own deep sleep. Let's float a little farther now, out of Earth's orbit entirely, and onto the surfaces of other worlds that have no atmosphere to erase, no oceans to swallow memory, no tectonic churn to reshape the land. Because if Earth forgets, maybe someone else remembers. The moon, cold, silent, still. For billions of years it has faced us with the same side, the same expression. It has no weather, no wind, no flowing water to erode, no atmosphere to scatter dust across its plains. What settles there stays. If a pre-human civilization reached space, if it walked among the stars even briefly, it would have seen the moon not as a distant light, but as a destination. And if it ever placed anything there, it might still be there now. This is one of the quiet hopes of those who study cosmic archaeology, that if something ancient ever left Earth, its traces might endure not on Earth itself, but on its airless neighbours. It's a mainstream fact that even the smallest marks, like footprints from Apollo astronauts, remain intact on the moon to this day. They will last for millions of years, perhaps longer, There is no rain to wash them away, no wind to soften their edges. If we can preserve our presence there in mere days, imagine what a civilization with millennia of time might have left behind. A lesser-known curiosity. In 2009, NASA's Lunar Reconnaissance Orbiter captured images of the Apollo landing sites. Not just shadows and dust, but the precise paths the astronauts took, the equipment they left behind. We have literal photos of human movement frozen in place on a body that hasn't changed in eons. Now imagine the same, but older. Imagine a smooth crater's rim, where nothing stirs yet something geometric protrudes. A fragment of metal alloy unknown to us, or a pattern in the dust, too regular, too aligned with the cardinal points, too clean to be natural, not proof, just a question. Could we miss such things? Astrophysicists and planetary scientists still debate how thoroughly we've scanned the moon's surface. We have high-resolution images of many regions, but not all, and even the best imagery can miss objects buried beneath the regolith, or shaded beneath overhangs, or camouflaged against stone. There are places on the far side of the moon that remain largely unstudied, shielded from radio noise, bathed only in starlight and cosmic silence. Could that be where the memories are? Let's not stop there. Mars. Cold, rusted, battered by ancient winds. Once, long ago, it had rivers, lakes, maybe even oceans. Now it is dry. But it too holds on to its history more stubbornly than Earth does. We've sent rovers there. Curiosity, perseverance, opportunity. And they've shown us ancient riverbeds, cracked clay, layered stone. Evidence that water once danced across its surface. If intelligent life ever lived on Mars, it could have been before the oceans vanished, before the magnetosphere faded. And just like Earth, Mars had billions of years to tell that story. A mainstream fact: some Martian meteorites found on Earth contain features that might resemble microbial fossils. The most famous, ALH T4001, sparked decades of debate. Most scientists now attribute the features to non-biological processes, but the spark of the question remains. And if we're still learning to detect microfossils, what else might we overlook? Perhaps Mars was not the home of an ancient species, but a refuge. If Earth's first civilization saw catastrophe approaching, a supervolcano, a gamma-ray burst, a runaway climate, they may have looked outward for safety, perhaps not to escape permanently, but to leave behind a message. Something carved into basalt, something buried in the dust, something waiting, and maybe we've already seen it, not as technology, but as anomaly, a formation too strange, a rock too regular, a line in the dust that does not belong. But we're not yet ready to hear. You might be breathing slower now, body soft, thoughts fluid. Let your imagination hover above the moon, the red plains of Mars, the silent slopes of cratered moons. In these places, time does not erase, it only watches, and maybe in the quiet, something watches back. We've lingered among the stars, floated through quiet orbits and Martian dust. But now let us return to a pivotal moment here on Earth, a turning point so profound it reshaped life forever, the Cambrian explosion. Roughly 540 million years ago, something changed. Life, which had moved slowly and simply for billions of years, suddenly diversified. In a geological instant, just a few million years, Earth's oceans teemed with new forms: hard shells, eyes, limbs, nervous systems. Complexity bloomed. The fossil record flares into brightness here. Trilobites, Anomalocaris, Hallucigenia, the strange and the familiar, all arriving in a rush of biological creativity. We often treat this as the beginning of the story. But what if it was not a beginning? What if the Cambrian explosion was a reset? A soft restart after something more ancient, more fragile, had risen and fallen and been forgotten. A mainstream fact. Prior to the Cambrian, life was almost entirely microbial or soft-bodied. These organisms rarely fossilized. The few that did, The Ediacaran biota remain enigmatic. They bear little resemblance to modern animals. Some may have been evolutionary dead ends. Others, we're still not sure. This gap in understanding leaves room for the idea that something may have preceded the explosion, not just in biology, but in awareness. Imagine a world where intelligence took an unfamiliar form, spread thin, perhaps, across colonies or networks. Organisms that grew slowly in the oceans coordinated their activity, responded to changes in subtle ways, not with eyes and hands, but with chemical gradients and pulses of bioelectricity. If such a civilization once bloomed in that long, soft Precambrian era, could the Cambrian explosion have buried it? A dramatic climate shift, a spike in oxygen, a change in the ocean's chemistry. All of these are considered contributors to the Cambrian surge. But what if they weren't just environmental changes? What if they were consequences? What if something collapsed and the planet, left open, bloomed anew? A lesser-known curiosity. Oxygen levels before the Cambrian were low but fluctuated. Some researchers believe early spikes in oxygen may have supported brief bursts of complexity, followed by collapses, life surging forward, then retreating, trying, failing, trying again. Could one of those early surges have gone further than we thought? Could it have crossed the threshold into sentience, then faded before it could leave a lasting mark? Astrobiologists still debate whether complex life needs stable oxygen to evolve minds like ours. It's uncertain if other chemistries could support similar processes, like sulfur-based respiration or entirely non-cellular structures. But many agree that the Cambrian explosion was not the only way life could have advanced. It's just the one that survived. So we sit now with this delicate idea, that the fossil record's silence before the Cambrian may not be emptiness, but erasure, that something lived, thought, perhaps even built or organised, just in ways we no longer recognise. Then a change came, not an apocalypse, not a war, but an environmental shift so deep it rewrote the rules of life, and the old forms, those soft ancient intelligences, were left behind. We are built atop their silence. If you're lying quietly now with thoughts moving slow as silt, perhaps you can feel the gravity of that idea, that even Earth's most celebrated moment of life, its great flourishing, may carry beneath it the faint shadows of something lost, not defeated, just outgrown, like roots beneath a forest, invisible but essential. And perhaps, in rare places, buried deep in the fossil record or encoded in genetic oddities, we might find faint echoes, muted signals, the last breath of the first breathers. Let your breath slow with that thought. Let the hush of deep time settle around you. The Cambrian was not the first chapter, just the first that we can still read. Now we drift even deeper, beneath the visible, beneath the tangible, into a realm of particles, pulses, and quiet theoretical whispers. What if the traces of a lost civilization aren't hidden in rock or fossil or orbit, but in physics itself? Let's explore a haunting question. Could intelligence leave behind a memory written into the very fabric of reality, into the particles that surround us? Could Earth's first sentient beings have encoded their legacy into the subatomic world? We begin softly with neutrinos. They're everywhere. Billions pass through your body every second without stopping, without interacting, without leaving a trace. They come from the sun, from stars, from radioactive decay deep in Earth's crust. They are particles of ghostly mass, nearly impossible to detect, but not entirely impossible. A mainstream fact. Neutrinos are observed using vast underground detectors, chambers filled with ultra-pure water or ice, waiting for the rarest of collisions. When a neutrino finally interacts, it produces a faint flash of light, a single, fleeting signature of something ancient and invisible. Neutrinos barely interact with matter. They slip through planets as though they were shadows. But some physicists have proposed something remarkable. If you could manipulate a neutrino stream, modulate it, structure it, you could, in theory, create a signal that would endure across time and space, almost impossible to destroy. This brings us to a soft speculation, neither proven nor dismissed, of neutrino memory. The idea that far in the past a civilization could have encoded information into neutrino patterns, not for communication between stars, but for storage, for survival. A message etched into silence itself. We don't yet know how to do this. Our technology is far too primitive. But if a species had millions of years and a different understanding of physics, might they have tried? A lesser-known curiosity, the cosmic neutrino background. Like the more famous cosmic microwave background, an afterglow from the Big Bang, the neutrino background is thought to permeate the universe. It is unimaginably faint, and we haven't directly detected it yet. But it is believed to hold information about the earliest moments of the cosmos. Now, imagine a species, ancient and subtle, who learned to leave fingerprints within that sea, not as messages to others, but as memory. What if Earth's first intelligence didn't care about being found in ruins or radio waves? What if they wanted only to remember themselves across eons, to store their identity in a form that matter could not erase? They might not have written in stone. They might have written in spin, in oscillation, in the quiet language of particles. It's uncertain if such a message would be discoverable. Astrophysicists still debate whether information can persist in quantum fields without degradation. But some hold out hope. After all, quantum entanglement, a phenomenon Einstein once called spooky action at a distance, shows us that information, in some forms, can be preserved in ways we barely understand. Perhaps we're surrounded by memory and do not yet know how to read it. Perhaps the very particles that make us are humming with stories. You might feel very small with this thought, and that's okay. You might also feel very held, because if memory can exist in the quantum field, then everything we are, every thought, every kindness, every quiet dream, has the potential to echo far beyond its moment. And perhaps, long ago, someone else understood this. Someone not human, someone from a time before ours, someone who chose not to build monuments, but to impress themselves upon the subtle scaffolding of the cosmos. If you're resting now, body warm and still, picture it. A signal, not of words, but of harmony. Not a message to us, but a memory of them, hidden in every breath, in every beam of sunlight, in every ghost particle that drifts through you in silence. Maybe we were never meant to find it. Maybe we are it. As we float farther into these soft tides of time and thought, a larger pattern begins to emerge, not just on Earth, but across the cosmos. If civilizations can rise, vanish, and be forgotten on our own planet, could the same happen everywhere? What if the universe is full of life, but silent, not because it never spoke, but because it has already fallen quiet? We arrive at the edge of an unsettling, beautiful idea, the silence between stars. We've long wondered why the sky doesn't sing. With billions of galaxies, each with billions of stars and perhaps even more planets, the odds suggest that intelligence should have emerged many times. And yet, we hear nothing. No voices across the void, no confirmed signals from afar. A mainstream observation in cosmology is this: the universe is very old. Over 13.8 billion years. Earth is young by comparison. If intelligent life is not unique to us, then surely someone, somewhere, should have reached out before now. So why the silence? One proposed answer is called the Great Filter. The idea that at some point in the development of life, either early on or later in its evolution, there's a barrier, a step so difficult, so improbable, that almost no civilization survive it. Some believe the filter is behind us, that life itself, or multicellular complexity or intelligence is the rare miracle. Others believe the filter is still ahead, that every civilization reaches a threshold of technology, of complexity, of environmental strain, and fails to pass through. But what if there's another possibility? What if civilizations do arise and fall, not with fire or failure, but with forgetting? What if they choose to go quiet? A lesser-known speculation among astrophysicists is that advanced civilizations may not be interested in broadcasting. The early hopes of radio signals and sky-spanning beacons may reflect our youth more than a universal pattern. Some have even suggested that mature civilizations might turn inward, focusing on simulation, on inner realms of thought, or on existing in forms we wouldn't recognize. It's possible we've misread the nature of intelligent life. We expect it to be loud, to build, to leave marks. But perhaps true advancement trends toward stillness, toward minimalism, toward harmony with one's world. Could Earth have seen this already? If a first civilization arose here, long before us, perhaps it didn't build empires, perhaps it didn't terraform or transmit, perhaps it evolved to live quietly within its ecosystem, never scaling beyond sustainability. In that case, we would find no ruins, no metals, no fires, only the echo of balance. You might feel a gentle ache in your chest as you lie there, pondering this vast silence. But that silence does not mean absence. It may mean completion. A whisper, not of failure, but of fulfillment. Civilizations may come and go like tides, rising, settling, receding. Not all need to conquer, not all need to last. Some may touch the stars briefly, then drift back into the hush of deep time. And perhaps we're not the first to wonder about this. Perhaps the silence we hear is not because no one ever spoke, but because they have finished speaking. And now they rest. There's comfort in this thought, that even if the universe is quiet, it has known voices. Even if the sky is dark, it has glowed before. If you listen closely, beyond the static of our own machines, beyond the pulse of nearby satellites, you might imagine a different kind of signal. One not made of sound or radio waves, but of stillness, of presence, like a candle burned all the way down, its light gone, but the warmth still lingering in the room. We may never hear these ancient civilizations, not on Earth, not on distant stars, but their silence itself is a kind of story, one that wraps around us every night. Let that silence soothe you. Let it cradle your thoughts as you drift, because the quiet between the stars is not empty. It is full of memory. Let's slow our drift now and turn our gaze inward toward a quiet question tucked inside the flow of history. What if time itself isn't what we think it is? We so often picture time as a line, a forward stream, one direction only. Civilizations rise, they fall, and they are replaced. But what if time, at its deepest level, curves, loops, breathes? What if the story of intelligent life on Earth isn't a straight path, but a cycle? There's a quiet philosophical idea, more poetic than proven, that intelligence might emerge again and again, not as a singular event, but as a rhythm, as a repeating breath of the cosmos, minds rising like waves, cresting for a moment, then sinking back into silence, only to return, not identical, not remembered, but echoing. A mainstream principle from cosmology may help us explore this. Entropy, the tendency for systems to move toward disorder. Over time, all things unravel. Stars die, matter cools, memories fade. But within this entropy, pockets of order can briefly form. Stars are born, planets stabilize, life appears, intelligence flickers to life, organizes itself, reflects. Then entropy returns. Could it be that civilizations arise like storms in this sea of chaos, brief, beautiful arrangements of energy and thought, only to dissolve and return again in some new form? It's uncertain if such cycles are real. Physicists still debate the nature of time itself. Is it linear? Is it emergent? Could the universe, or even just a world like ours, reset itself? Not physically, but in structure, in pattern. Consider Earth. The planet has reset many times. Mass extinctions have swept the biosphere clean. The Permian extinction, for instance, erased 90% of all marine species. The Chicxulub impact ended the reign of the dinosaurs. Each time life began again, not from scratch, but from silence. A lesser-known detail, some evolutionary traits have appeared more than once. In entirely separate lineages, this is known as convergent evolution. Eyes evolved independently in different species. So did flight. Intelligence itself may be another example. Perhaps awareness is not a fluke, but a tendency. A recurring melody that life returns to when the conditions are right. If so, then intelligent civilizations, ours included, may not be the first or the last. They may rise when the timing aligns, when the climate is stable, when the chemistry is right. And when those conditions change, they fade. The cycle pauses, only to begin again sometime later under new skies, on Earth or elsewhere. You might be lying very still now, breathing in the quiet. Let this idea wash over you, not with urgency, but with gentleness. If civilizations come and go like seasons, then perhaps the universe is not failing to produce life. Perhaps it is constantly doing so, like a garden that blooms at intervals, each flower unaware of the one before it. We often speak of the end, of singularities, of collapse. But what if endings are not final? What if every fall makes room for a rise? A civilization may vanish without a trace, but its possibility remains. Like a seed buried deep beneath the soil, waiting for spring. You and I, right now, may be walking on ground that once held minds like ours, or entirely unlike ours. Minds that dreamed, wondered, created. Minds that may have passed through this moment before, in some distant loop of time. Or perhaps those minds are still with us, not in fossils, but in patterns, in instincts, in the deep structure of thought, in the recurring shapes of story and science and soul. Maybe you felt it. That strange déjà vu when staring at the stars. That sense that we are returning to something, not discovering it for the first time. Perhaps the reason it all feels so familiar is that it is. Let that idea settle gently in your breath. Let it remind you that we are part of something wider than memory, wider than time, that the universe may forget, yes, but it also remembers in rhythm. And we, just now, may be the latest note in a very old song. Now let's turn our gaze to something truly ancient, something older than any mountain, any ocean, any whisper of life on Earth. Let's look toward the light itself. Scattered across the sky, beyond what eyes can see, is a faint, persistent glow. It does not flicker. It does not change. It is not the light of stars or galaxies or nebulae. It is the light of the beginning. The cosmic microwave background, or CMB, is a soft afterglow from the Big Bang, a sea of ancient photons that has been drifting through the universe for nearly 13.8 billion years. These photons were released when the cosmos first cooled enough for light to travel freely, just a few 100,000 years after time itself began. And they are still here, passing through you now, quiet, relentless, so faint they can only be seen with radio telescopes, which render them not as pictures, but as temperature maps. Tiny fluctuations, subtle patches like a faded fingerprint. A mainstream fact, the CMB is nearly uniform, but not entirely. Its gentle fluctuations helped shape the structure of the universe, guiding the formation of galaxies, stars, and eventually planets. It is the cosmic seedbed, the original backdrop to everything. Now here's the question that pulls us back toward our wondering. Could that light, this ancient whisper, carry more than we realize? We don't mean deliberate signals or messages encoded by hand, but something subtler, something embedded in the structure itself. Could a civilization long gone have touched this field? Some theoretical physicists have wondered aloud, if a civilization existed before the known universe as we understand it, before our current expansion, might it have found a way to impress information into the very geometry of the cosmos? It's speculative, gentle, perhaps even poetic more than practical. But in the realm of cosmology, even poetry has space to breathe. There is a lesser-known theory called conformal cyclic cosmology, proposed by Sir Roger Penrose. It suggests that the universe goes through cycles, not in a literal reset of matter, but in its geometry. That the far, far future of one universe, the point where all matter decays into light, can somehow become the beginning of the next. And if that's true, perhaps civilizations at the end of time could send faint imprints across cycles. Not messages, not languages, but shapes, echoes, tiny irregularities in the cosmic background that don't belong. Astrophysicists still debate the validity of this idea. Some believe they've seen odd concentric rings in the CMB, patterns that don't fit the standard models. Others say it's statistical noise. It's uncertain if any of it is real. But here, under the velvet sky, the thought is enough. Imagine a civilization so old, so patient, that it outlived stars, that it watched galaxies dim and fade, that it existed not in cities or planets, but in orbiting networks, black hole shells, or structures shaped by gravity itself. And at the edge of time, with no more energy left to harvest, no more matter to manipulate, perhaps they turned inward. They compressed their story into something small, compressed it into geometry, into entropy, into the ripples of the background field itself. And when this universe began, when expansion bloomed from nothing, those patterns remained, buried in light. Perhaps the CMB is not just the echo of birth. Perhaps it is also the last breath of a forgotten intelligence. If you're lying still now, body relaxed, eyes closed or nearly so, picture that light as a soft wind. You can't see it, you can't hear it, but it moves through you, through the earth, through everything. Each photon a traveller from the edge of time. Some may have passed through galaxies, through plasma, through the earliest clouds that would become stars. Others have been floating through empty space, uninterrupted since the beginning, and now they reach you. Not to tell you something urgent, but to remind you, gently, that everything has a memory, that even light can carry stories. Not stories with words, perhaps, but stories written in warmth, in balance, in presence. So the next time you look up and feel the hush of the stars, remember, some of the light that touches you tonight may carry the quiet echo of a civilization not just older than ours, but older than time as we know it. We're nearing the edge of our long drift now, the hush where questions deepen and answers slow. And so we pause to ask one of the quietest, hardest things of all. What if we never know? What if Earth's first civilization, if it ever existed, remains forever unreachable to us? Not because we're not looking, but because some things were never meant to be found. We live in an age of discovery. We map genes. We peer billions of light years into the past. We build machines that can see into atoms, simulate galaxies, and translate ancient languages. And yet, beneath all this knowing, there is a truth we cannot escape. The past is not obligated to leave us clues, especially when time itself is the editor. A mainstream geological truth, erosion, subduction, and planetary resurfacing have obliterated most of Earth's oldest surfaces. The seafloor recycles every couple 100 million years. Even ancient mountain ranges are ground down to dust. The deeper we dig, the less we find, not because nothing was there, but because Earth is not a museum. It is alive, in motion. a planet with no desire to preserve our curiosity, and so we may never find a fossilized tool older than time. We may never unearth a circuit etched in ancient stone. We may never decode a pattern in isotopes or orbits and declare with certainty, yes, this was theirs. A lesser-known fact, even on human timescales, records fade fast. The oldest complete written stories we have are barely 4,000 years old. Beyond that, fragments, bone etchings, oral traditions half remembered, cities swallowed by forest and sand. Time doesn't just pass, it sifts. Astrobiologists still debate what we should expect to find if an earlier intelligence ever existed. Some say we would see synthetic elements, non-natural isotope ratios, or structural anomalies. Others argue that intelligence might leave no trace at all, especially if it lived lightly or evolved along paths radically unlike ours. It's uncertain if we even know what we're looking for, and maybe that's okay. Maybe some mysteries don't need resolution. Maybe part of being a thinking species, of stepping into the long night of the cosmos, is learning to rest in uncertainty, to wonder without expecting, to listen without hearing, to search, knowing the silence might be the only answer we ever receive. But that silence is not empty. It's full of potential. It invites us to tread gently, to pay attention. To remember that not all legacies are written in stone. Some are written in the way we look up at the stars and imagine who else might have stood in our place. That act of wondering, of reaching, of dreaming across time is a form of connection all its own. So maybe we won't find ancient ruins or lost technologies. Maybe we'll never decode the signature of Earth's possible predecessors, but in imagining them, we honour them. Even if they never existed, the very possibility of their presence deepens our understanding of time, of life, of ourselves. And if they did exist, hidden, erased, forgotten, then every quiet moment of awe, every breath we take in wonder beneath the stars becomes a kind of reply, a soft voice answering across the ages. We're here now, and we remember you, even if we never knew your name. If you're lying quietly now, feel your body soften into the bed. Feel the hush of this moment surround you. The world is quiet, the universe vast, and in that vastness there is something tender. Not everything needs proof to matter. Some things only need possibility. And now, as we arrive at the edge of this long lunar tide of thought, we circle gently back to where we began. Not to Earth as we know it, but to Earth as it might have been. Quiet, unwritten, watching. All around us the stars continue their ancient paths, unaware of the questions whispered below. We look up and wonder if we are alone in the universe. But maybe, just maybe, the more astonishing question is whether we were ever truly alone right here, on our own world. What if Earth itself is the archive? A memory not held in books or ruins or artifacts, but in structure, in rhythm, in the very way life repeats and recomposes itself. Every time a forest blooms where another once burned, every time a species rediscovers a trait that once disappeared, every time an eye opens to the stars and thinks, what else is out there? Maybe that is the trace, not stone tools, not monuments, but recurrence and the quiet gift of wonder. A mainstream biological observation helps us here. Evolution reuses what works. Genes are repurposed, adapted, reshaped. Structures evolve again and again, wings in birds, bats and insects, eyes in squid and humans, intelligence in octopuses and apes. Earth favours echoes. What if civilizations are part of that echo? Not rare, not inevitable, but cyclical. A pattern the planet follows when conditions are right, not just once, but many times, each one rising from the roots of the last, unknowing, unremembering. What if we are the echo? a quiet return to a song sung long before. A lesser-known idea in evolutionary biology is the concept of atavism, when ancient traits reappear. A tail in a human embryo, teeth in a chicken, reminders that the past still lives in the present just beneath the surface. Could consciousness itself have an atavism? Could the urge to explore, to build, to ask the night sky for meaning, be not a first, but a reawakening? Perhaps our very curiosity is the footprint we've been looking for. Not theirs, ours, reborn. Astrophysicists still debate how long civilizations like ours might last. A few hundred years, a few thousand, a million. It's uncertain if intelligence ensures survival, or if it simply burns faster, brighter, and disappears more completely. But maybe endurance isn't the point. Maybe the point is to wonder while we can, to see this blue world not as a blank slate, but as a palimpsest, a layered document, rewritten over time, still carrying the faint indentations of what came before. And if we never uncover the truth, that's all right. Because the act of asking opens something beautiful. It opens humility. It opens perspective. It opens the awareness that time is larger than us, and that we are part of its slow, dreaming breath. If you're resting now, deeply still, perhaps you can feel the earth beneath you, not just as rock or soil or foundation, but as memory, not specific, not legible, but alive. Perhaps the first civilization to live here never saw the stars the way we do. Perhaps they had no telescopes, no mathematics, no metal. But perhaps they paused, at least once, in silence, and felt wonder. And now so do we. Separated by epochs, connected by awe. So we come to the end of our journey, but not the end of the question, because the question lives on, in the way we tilt our heads to the sky, in the way we ask what else might have been, in the way we settle down in the quiet of night and listen. So now we rest, as starlight settles gently across our thoughts. We've wandered through ancient oceans, silent moons and vanished plains. We've imagined what Earth might have held before memory, before writing, before us. Whether anything ever stirred with intention in those deep ages, we may never know. But what matters tonight is not the certainty. It's the calm of not needing it. Because sometimes the greatest gift is not an answer, but a question that stays. A soft, echoing maybe. Maybe we're not the first to wonder. Maybe Earth remembers more than it reveals. And maybe the quiet curiosity we carry is part of something much older than we know. So breathe now, slowly. Let your body relax. Let your thoughts blur at the edges, like mist over an ancient shore. There is no rush, no urgency, only the slow turning of a world that has always been here, dreaming beneath the stars. The sky is still. The ground holds no secrets tonight. Only you, only this moment, and the quiet possibility that you're part of something wider, deeper, and more beautiful than can ever be fully named. Thank you for drifting with us. Sleep well, sleep deep. Sleep as if the stars are listening, because maybe, just maybe, they are.